the solution. The colligative properties are those properties of the dilute solution of non-volatile solute whose value depends upon the concentration of the solute particle in the solution but not on the individual identity of the solute. There are four different types of the colligative property. First is relative lowering of vapor pressure of the solution, osmotic pressure, elevation in boiling point, and depression in the freezing point. Actually, in case of colligative properties, we know that the colligative properties generally depending only on the number of atoms, number of particles, number of ions, number of molecules of the solute in a definite amount of the solvent, but not depending on the nature of the solute. The first colligative property, that is relative lowering in vapor pressure of the solution. We know that when we add the non-volatile solute, the vapor pressure of the solution will start to decrease because the non-volatile solute not able to produce the vapor pressure, and it will generally decreasing the solvent molecules to escape into the vapor phase. Therefore, the tendency of the solvent molecules will decrease and cannot escape into the gaseous phase. Therefore, the vapor pressure of the solution will start to decrease by the addition of non-volatile solute. Therefore, the formula that we will get here by the addition of non-volatile solute will be equal to P naught A minus PS upon P naught A, that is equal to WB upon MB into MA upon WA, which will give you the relative lowering in the vapor pressure of the solution. Here P naught, that is vapor pressure of the pure solvent, and P is the vapor pressure of the solvent in the solution, that is vapor pressure of the solution. Delta P is P naught minus P, that is lowering in vapor pressure. This lowering in vapor pressure is depending only on the amount of the solute that we are adding in the solution. This decrease in vapor pressure of the solution, lowering in the vapor pressure of the solution, that is P naught A minus PS upon P naught A is equal to WB upon MB into MA upon WA. By this formula, we are able to calculate the molecular mass of the non-volatile solute which is present in the solution. This is the formula that we are using here to determine the molecular mass of the solute, that is MB, can be determined by using this formula. P naught A minus PS upon P naught A is equal to XB, where XB is the mole fraction of the solute. Here we can write XB is equal to NB upon NA plus NB, where NB can be neglected in the lower term because the value of the NB for the dilute solution is very less than Na. Therefore, we are getting this formula, that is here del P naught A minus PA upon P naught A will be equal to delta P upon P naught A will be equal to WB upon MB into MA upon WA. The second colligative property, which is known as elevation in boiling point. Now we know that when the non-volatile solute is generally added in the solution, it will cause the lowering in vapor pressure. Due to the lowering in vapor pressure, the boiling point of the solution generally increases. This increase in the boiling point is known as elevation in boiling point. Now, what is boiling point? The boiling point of the liquid may be defined as the temperature at which the vapor pressure becomes equal to atmospheric pressure. Now, when we plot the graph between vapor pressure and temperature, here we are getting two curves. The curve AB, which represents the curve for the solvent, the curve CD is represent for the solution. Now, this is the point which is known as T0 when the vapor pressure of the solvent become equal to atmospheric pressure. Therefore, this is known as the boiling point of solvent. Now, this is the TS, which is the boiling point of solution. At this point, we will get the vapor pressure of the solution is equal to atmospheric pressure. Therefore, this is the boiling point of solution. Now, what is this delta TB? Delta TB is the elevation in boiling point, which is equal to Ts minus T0. That is equal to elevation in boiling point. This elevation in boiling point, its magnitude depends on the lowering of vapor pressure, that is delta P. This shows that delta TB is directly proportional to delta P, and delta P, according to Raoult's law, is directly proportional to XB, that is mole fraction of the solute. Therefore, delta TB is directly proportional to XB. Now, delta TB is equal to K XB. What is K here? K is known as the proportionality constant. K is known as the proportionality constant. Now, delta TB is equal to K NB upon Na plus Nb. Here, if we open the terms, that is Nb and Na, then delta TB is equal to K Wb upon Mb upon Wa upon Ma plus Wb upon Mb. For the dilute solutions, we know that Wb upon Mb is very less than Wa upon Ma, and hence Wb upon Mb can be neglected in the denominator as compared to Wa upon Ma. Therefore, delta TB is equal to K Nb upon Wa into Ma, where Nb upon Wa, when we take the Wa in kg, 1 kg of the solvent is there, then it will represent the molality, number of moles per kg of the solvent. Therefore, Nb upon Wa represents molality, that is delta TB is equal to K into Ma into molality. K is the proportionality constant, Ma is the molar mass of the solvent. Now, these two constants, when we multiply it, then we get the third constant, which is known as Kb, where delta TB is equal to Kb into M. Now, what is here? Kb. This Kb is known as the molar elevation constant, which is known as molar elevation constant, and it is also known as ebullioscopic constant or boiling point elevation constant. All these are represented by using the symbol Kb. Now, as it is clear that the elevation in boiling point depends upon the relative number of the moles of the solute particles, but does not depend upon the nature of the solute. Therefore, the elevation in boiling point is the colligative property. But here remember one thing, the boiling point is not a colligative property, but the elevation in boiling point is a colligative property because it depends upon the number of the particles of the solute present in the given amount of the solvent. Now, when we take the molality M is equal to 1, then delta TB is equal to Kb. Now, the elevation in the boiling point when 1 mole of the non-volatile solute is dissolved per kilogram of the solvent. Therefore, the units of Kb is equal to Kelvin kg per mole. Suppose if we want to determine the value of Kb, which is known as the molar elevation constant, that will be equal to R T square upon 1000 into Lv, where Lv is the latent heat of vaporization, and here R Tb, where R is the universal gas constant, Tb is the boiling point of the pure solvent. Boiling point of the pure solvent.